Hello and welcome to the Chemistry Academy. In this video we're going to be going over average rate calculations and how to interpret reaction rate results that's specific to National 5 Chemistry. It may also help you out if you are crashing higher chemistry. So let's get into it. If you're not 100% sure on how to carry out experimental procedures to monitor the rate of reaction and gather all these results, then check out my video in my National 5 Chemistry playlist called Monitoring the Rate. But once you've gathered all of your data, which is normally collected at regular time intervals, the data will often be presented as a table, or sometimes you'll have it presented to you in the SQA exams as a graph. So it's important you know how to interpret the data when it's displayed in both different forms. Now, most of the reactions that you will follow the rate of in National 5 Chemistry do produce a gas, so quite often the quantity measurement is a volume of gas. This can be different, sometimes it can be a mass of a substance, but the results will tell you whether it's a volume of gas or a mass, so you don't need to worry too much about that. When you're asked to calculate the average rate, this is the equation you would use here, and you can find that on the contents page of the data booklet, so you don't need to remember it. And you just need to bear in mind that this delta triangle, it's the Greek letter delta, means change in. So we've got the change in quantity divided by the change in time, and that would give us the average rate over a certain period of the reaction. So just going to go quickly over how to use this equation, and then we're going to look at how else you could be asked to interpret the rate of reaction results. So let's say the question is asking us to calculate the average rate for the first 20 seconds of a reaction. So that means we're going from 0 seconds to 20 seconds and trying to work out what the rate is. My advice would be to write this line of working down and then put the times that you're interested in on the bottom underneath the division line. So if the question was the first 20 seconds, we would have 20 minus 0. Okay, so write out this working, draw your division line, and then put the time numbers on the bottom. It is very important the time goes on the bottom. A lot of the time people put it upside down by accident, so that's just a habit you can get into. Anytime you're doing our calculation for calculating the average rate, write down the equation, draw your division line, and then put the time numbers on the bottom. Once we've done that, all we have to do is look to see what the quantities were at these times. So at 20 seconds, it was 25 centimetres cubed. So I will write a 25 above the 20, and at 0 seconds, it was 0 centimetres cubed. So once we've got the numbers in, then it's just a case of simplifying down and actually working out the calculation. 25 over 20, and then you would put that into your calculator, which I don't currently have, and you would get the answer 1.4, I think. I'm gonna have to double check that on a calculator after this. Now, when it comes to the units, normally the question in the exam will give you the units, so it would say calculate the average rate in centimetres cubed per second. However, if you aren't given the units, it means you get a mark to work them out. So all you have to do is do the quantity unit per the time unit. So our quantity unit was centimetres cubed, our time unit was seconds, so the units for this would be centimetres cubed per second. So you can write that as centimetres cubed stroke seconds, or the -1 power. If you do both, that's like writing per, so it either has to be one or the other. So either the dash and the s, or the s to the -1. This is the form that the SQA will normally write. If we were asked to calculate the average rate between 10 and 30 seconds, we would do the exact same thing, but we would have 30 minus 10 on the bottom here, and then the quantity at 30, which was 30, minus the quantity at 10, which is 15. So it would end up as 15 over 20, and then you would just put it in your calculator. And it's as easy as that. Moving on to how you could be asked to interpret these rate of reaction results in other ways other than just calculating the average rate. So You need to identify key points of the reaction, and normally that would be where the reaction has stopped. So the reaction stops when there's no more product produced. So in the case of a gas being produced, you'll see no change to the volume of gas. Or if it's a mass of something, there'll be no change to the mass. You're basically looking for the point at which the results stopped changing in number. So if we were asked to predict when the reaction stopped in this set of results, we would be looking at, right, the final volume it got to was 32, it stayed at 32 for a couple of intervals. The reaction clearly stopped once it got to 32, so suggesting a point that it got to 32 must have been somewhere in between 30 and 40 seconds. Okay, so you can't say for sure it stopped at 40 seconds because it's already got to 32 here. So you would most likely pick a number between 30 and 40. Now I would probably pick a number that was a bit closer to 40 than it was to 30, but the SQA give you a range of values you can be within between, and it would most likely be any number between 30 and 40. So you could have it's finished at 32 seconds, 35 seconds, 37 seconds, as long as it's a number between 30 and 40, the point at which it first got in the results to the final volume and the data point before that. If you're looking at it from a graph perspective, you're looking again for what the final volume was. So the final volume occurred at this volume here. I've not put a number scale on here, but it doesn't matter. So we would then be looking for the time that it first got to that volume. So we would say that would be about 3 minutes in my sketch here. Okay, so we would say this is probably where it first got, the line first got to this level here, and then we go down to see that that would be around 3 minutes. So once the results flatten off, the numbers don't change, that's when your reaction stops. The other thing they'll quite often ask you about is why reactions slow down as they proceed. So you may notice in any result that you get a really steep production of product in the beginning and then it starts to taper off. Same here, the line's quite steep here and then it starts to curve and flatten out. This happens because for any reaction, doesn't matter what the reaction is, because as the reaction proceeds, your reactants are getting used up. So if you've not got enough as many reactants left, you're not going to have as fast a reaction. So this is just one thing to remember, that reactions slow down as they proceed due to the reactants being used up. So if you get asked in an SQA exam why the reaction slows down as it proceeds, it's just because the reactants are being used up. One last thing I'm going to talk about in this video is how the amount of reactant you have can affect the amount of product you produce. Now, the amount of product you make is proportional to the amount of reactant you have. So by that, what I mean is if you were to halve the amount of your reactants, you would probably halve the amount of your products. The reason I say probably is because if a reactant is in excess, changing it or adding more of it won't make any difference. The reactant in excess means that you have more of it than you need. So by adding more on top of that, you're not going to make any extra product. In National 5, excess isn't talked about too much. However, sometimes when they're talking about the reaction between calcium carbonate and hydrochloric acid, they'll quite often mention that the hydrochloric acid is in excess. What that means then is that if you increase the concentration of your hydrochloric acid, your reaction will go faster because you've got a higher concentration, but you won't make any more product because you already had an excess of hydrochloric acid already. So you'll speed up the reaction, but you won't make any more. However, if you had doubled the calcium carbonate, which wasn't in excess, you would make double the amount of product. Okay, so if you're adding more of something that's in excess, you won't make more product, you'll just make the reaction happen faster. If you add more of something that isn't in excess, then you will make more product, and it's proportional to how much more of that reactant you added. If that confuses you, don't worry too much. It can take a little while to get your head around it, but like I said, they don't focus on it too much in National 5. what sometimes happens is you'll get questions with graphs like this and be asked to identify which graph would occur if you were to double the concentration of your acid. So if the acid's in excess, it's going to go up quicker, but it'll finish at the same place. Okay? If you were to add double or half the amount of reactant, let's say half the amount of reactant, it wasn't in excess, then you would only make half the amount of gas. Okay? So I will add this to the graph. So let's say we're halving our amount of reactant, it will go up more slowly to only half the volume. So if you add more of something that's in excess, your reaction will occur quicker, but it will level off at the same place. Just starts to level off sooner because the reaction occurs faster. But like I said, because you're adding more of something that's in excess, you're not going to make any more product. Hopefully that helps you out with calculating the average rate and interpreting rate of reaction results. Like I said, if you need more help on the experimental procedures behind monitoring the rate, check out the other video in my National 5 Chemistry playlist. If you're looking for help on how to learn the effects of factors on rates of reactions, then I'll have another video on that in my National 5 Chemistry playlist. But failing that, if you found this helpful, please give this video a like. Please subscribe to the Chemistry Academy to keep up to date with future tutorials, and have a great day.